Hello students, I am D.N.Thatoi. Welcome you again to our new YouTube video channel Physics Sketch. This is your fourth video class. In the last video class, that is 3, in video number 3, I have told to solve these two problems. They are very interesting problems. Seems to be difficult or like this, but it can be solved very easily. Please go through the questions. So now let us solve this problem first, then we will go to this problem. So now in this problem, so what is given? Now a block is given. It is kept on a rough horizontal surface. The coefficient of friction is mu. Listen carefully. Very interesting problem, very easy. So now a block of mass m is placed on a rough horizontal surface mu. So the height of the block is, total height of the block is b. The center of mass is acting at the middle. So since the center of mass is acting middle, this height is equal to this. So when a force will be applied on the block, so what are the changes in this block that I am going to explain. Look at here. So before that, if no forces are acting, weight is downward. So ground will give a reaction. That reaction is equal to R. The reaction R, mg, they are equal. The reaction are equal. They are equal, opposite and collinear. So it is a equilibrium by two forces. Again, to make this body in equilibrium, these two forces will be equal, opposite and collinear. So here the R is upward, mg downward. They should be equal and they should lie in one line. That is very important, so that the body will be in equilibrium. Now, if I pull the body, so now I am pulling the body, I am making the second diagram. Look here. Now, if I pull the body, what are the changes there and how to solve the problem? Now, I will pull the body. So, when I will pull the body and the pulling force is given, let the pulling force is given, it is passing through the center of mass. Let P is pulling force. Now, the weight of the body acting at the CG, that is equal to mg. This is the center of mass. Now center of mass is above the ground by what height? That total height is 2b. So this height is equal to b. So this height is equal to b. Now when I will pull the body by a force p, so definitely in the condition of limiting equilibrium, the friction force will be acting. That limiting friction is equal to mu r. Okay. Again. So when I will pull the body, the applied force P is such that so the body is coming to limiting equilibrium. If the body is coming to limiting equilibrium, then the limiting friction force will act to opposite direction. So friction force is to right, applied force to left. So in limiting equilibrium, so right hand side force is equal to left hand side force. So now I am writing the problem. Right hand side force is P, left hand side force is equal to mu r. And the weight is equal to acting mg. Now the interesting part is here the reaction was acting upward and it is passing through the center of mass. Now here the reaction will never pass through the center of mass. The reaction will go to right, and this reaction will go to right by how much? So now it will extend the weight force. Okay, it will extend the weight line. This is the weight, and the weight line will be extended. So this reaction has shifted to right by x. If this reaction is shifted to right by x, question is what is the value of x? That is my question. And the point where the reaction will be acting, that is called the sheet of reaction. Sheet where we are sitting, that is called the sheet of reaction. The reaction will be shifted to this point, and by distance x, that x is required to find out. So how to find the reaction here? Now I know that when a body is equilibrium, total right hand side force is left hand side. Yes, P is equal to mu r. The total downward force is upward force. Yes, that is equal to R is equal to mg. Upward is R, downward is mg. Now by putting the value of R here, what I will get? Now put the value of R here. Then I am getting that is equal to mu mg. So P is equal to mu mg. So I got the value of P, that is equal to mu mg. Now the equilibrium criteria, there are three equilibrium criteria. One equilibrium criteria is clockwise moment is equal to anti-clockwise moment. Second is total upward force is equal to downward force. Third is total right hand side force is equal to left hand side force. If these three conditions are applied, then I can say the body is in equilibrium. So since I have applied upward force is downward force, this equation I have applied. Upward is downward, this I have already applied. Left hand side is right hand side, this already I have applied. But I have not applied clockwise moment is equal to anti-clockwise moment. So when the clockwise moment will be equal to anti-clockwise moment, then the problem will be complete. So this part I am removing. Now come to this problem here. So why clockwise moment, anti-clockwise moment? Because P is acting here. Look, P is acting here to right, and mu are acting to left, but they are not collinear. What is the distance between them? The distance between them is B. So this is equal to P. This is equal to mu r. Mu r is equal to mu mg. So P is equal to mu mg. So they will develop a clockwise moment. If they will develop a clockwise moment, then who will provide an anti-clockwise moment? Now R is acting to upward and downward is acting is mg. So mg and R, they will develop which moment? Anti-clockwise moment. Look here, this is upward, this is downward. They will develop a couple. This is called moment of couple. The moment of couple is anti-clockwise. Here the moment of couple is clockwise. If the clockwise couple is equal to anti-clockwise couple, then the body will be equilibrium. Then my problem will be finished. Now write down the third criteria of the clockwise moment is equal to anti-clockwise moment to solve the problem and complete the solution. Now come to the clockwise moment is anti-clockwise moment. Now we will begin. This moment is clockwise. What is clockwise moment? P into B. So what is P? Now mu mg. So clockwise couple, clockwise moment of couple is equal to anti-clockwise couple. So clockwise moment is given by mu mg. Mu mg the force that is equal to into B is equal to anti-clockwise couple is given R and mg. Distance between them is x. So this distance between them is x. That is equal to mg into x or R into x, same thing. That is equal to mg into x. Then I can write mg cancelled out. So the sheet of reaction, normal reaction is shifted to right by how much? Is equal to mu b. So this is the answer to the problem. So when forces will be applied, actually reaction is not passing through the CG. CG reaction slightly shift to right. Why it is slightly shifting to right? Because the applied force and friction, they are developing a clockwise couple. To counter the clockwise couple, there should be anti-clockwise couple. Then, if three conditions are satisfied, then we can say the body is in equilibrium. What is that? Upward force is equal to downward force, left hand side force is equal to right hand side force, and clockwise moment or clockwise couple is equal to anti-clockwise couple. So, the solution of the problem is equal to x is equal to mu b. That is your solution. Now come to that question. Okay, please note down. Please note down. Now come to the second part of the question. So when I am writing and I am explaining, so I am giving sufficient time in between. Please note down. Otherwise you will forget. Okay, otherwise you will forget. Please note down. Now question is, two blocks are there. This is the block A. This is the block A. This is the block B. Mass of both the blocks are same. The coefficient friction is same. Now between the two blocks you push a rod. So and when you push a rod and the rod will be pushed. So this body will go to right and this body will go to left. The question is, which body will move fast? And this force P applied is gradually applied force. Gradually increasing load. The gradually increasing load. So gradually, slowly go on increasing. So when the load will be slowly increased, then whether A will slide to left or B will fly to right, or who will move to right or left? So how to decide? So how to decide? Please go through the figure. So I am explaining. Look. So these are the two blocks. So anyway, so when this body will be going, so this point and this is the contact point. Let the contact point is A here. Let the contact point is B here. So now this block A will give a reaction on the rod in this direction. So this body B to the rod will give a reaction in this direction. Now to solve this problem, I am making the diagram here carefully. Look here. Now this is the block. This is your block. This is placed on the ground where friction is present. This is another block. Both the blocks are identical. Friction is same. Mass is same. So every condition is same. Then we have to decide which block will move first. Now in between the rod is inserted. And question is that the rod is tightly fitted between the two walls. And between the rod and the wall there is no friction. So that is the condition. So now it is not touching the ground. The rod is not touching the ground. So the rod is tightly fitted between the two walls. It is between the two walls. Okay, this is the two walls. It is tightly fitted. So now when I push the rod to right, when I push this way, let's say pushing is P, then at this point it will keep in contact like this. Is a exaggerated figure because the clearance between them is big. So now problem will be tilted, so angle will be there. But it is not the case. So initial figure like this and it will be touching here. So when I push the body, so this body, but name of the body is B. B will give a reaction here. This reaction is equal to say R1. So A will give a reaction here. That reaction is equal to R2. Now make the free body diagram of the rod. If you make the free body diagram of the rod, you will find out here you have applied force P. Okay. Now at this point the block B will give a reaction. That reaction is equal to R1. The block A will give a reaction here. That is reaction is equal to R2. So at the moment of in the limiting case, so when you are applying force, the applying force is gradual. A limiting case, when a case will come when so one body will start to move. In limiting case, this rod is in equilibrium. How the rod will be equilibrium? Now let us consider equilibrium of the rod. Equilibrium of rod. The rod will be equilibrium when total right hand side force is equal to total left hand side force. What is right hand side force? Right hand side force is P and R2. So that is equal to P plus R2 is right hand side. Who is left hand side? R1 is alone. That is equal to right. So this shows that R1 is equal to P plus R2 or R1 is greater than R2. So now the answer is over. Now you are coming to the conclusion. The conclusion is R1 is greater than R2. Now R1 is greater than R2 means on this body, because this reaction is on this body R1, on this body this is a force R2. So this body will be acted upon by a force R1. This body will be acted upon by R2. Which is greater? R1 is greater. So body B will move fast. So body B will move fast. This is the answer. So the body B will move fast. So how I have decided, how I have solved, please go through the explanation. So now if this video is interesting, you are showing interest, then you find interest, then please like and subscribe and share, please. And also, so now please attend or continue to attend all the video classes or listen through the or go through the video classes. So in every week I am going to solve few problems, very interesting problems based on IIT JEE and IIT Main, JEE Advanced and JEE Main. Thank you.